First, hydrostatic law. It states that rise states the change of pressure rate of change of pressure changing pressure in pressure in a vertical direction or along the depth is equal to weight density of liquid at that point. Now, how to derive this formula means changing rate of change in pressure. Suppose jet direction, vertical direction, consider jet. This x y jet, this vertical direction with weight density or rho g. This is the formula of hydrostatics law. Now derive this equation. You can say or liquid or fluid. Fluid. Now assume this is a container. It's full with liquids. This is the free surface, and consider a small element. Consider a small element whose cross-sectional area is A, and this is the mass density of liquid, equal to rho. And here at this upper plane the pressure is Pz, and the height of this is suppose dz. Now consider this is z, this is x, and this is the y direction, and dz is and here also in the lower plane there also a pressure Pz plus Dz. Because of height there is more pressure at the lower plane. Now draw the free body diagram of these elements. FBD, free body diagram of these elements. This is suppose cross sectional area dA, small element dA. This is the cross sectional area of elements. From the Taylor series, Taylor's series, fx plus dx equal to function of fx dx. Say the formula is fx plus differentiation dx into fx fx into dx. Then that's from the Taylor series, and you can write delta x square fx into dx. Understand? From the Taylor series. So now Pz plus Dz, you can say P in Pz plus d by dz plus Pz into dz. So at upper portion the pressure force P into dA, and at lower portion pressure force is dz plus Pz into dz into dA. And here also weight is acting. There is weight acting. Weight equal to rho g, weight equal to into volume dA into dz. Weight equal to dz is acting here. Now fluid at rest, the summation of fluid at rest means this is static condition, summation of fz equal to 0. We consider the downward force is negative and upward force is positive. Now upward force is Pz into, you can directly multiply dA plus dz Pz plus dz into dA minus downward force is negative, consider, and also weight rho g dA into dz equal to 0. And at this condition this one cancel out. Now dz plus pj dj into dA, rho g into dA into dz equal to 0. This one cancel out, so dpz by dz equal to rho g, and this is the partial derivative. You can write this one, p dz by dz equal to rho g or gamma. This is the proof. This is the proof of statement of the hydrostatics law. And one time एक समय में ESI एग्जाम में आया था एक क्वेश्चन. There was 4 option. One is this option, another option is dz into dz equal to minus. Which one is correct? This one is correct because dimension is not, direction is, z direction is not mentioned. For standard, this is x, this is z, this is y. This is the standard. This is the standard coordinate. So here we consider z direction is downward, but when consider the z direction upward, that time the formula will be this, and this one correct if the z direction is not mentioned, but z is mentioned, that time this equation is correct. Understand? So you can say the rate of change of pressure along depth is equal to mass density of liquid at that point. So pressure is a function of z, but pressure is not a function of x, y. Please understand. Suppose a container suppose this is the free surface, and this is point A, this is point B, this height is h. So at that case, the pressure pressure z at A equal to pressure ZB. So pressure at this plane, the pressure is same throughout the plane. Also from the Pascal law, Px in A points, we know the Pascal Px, Py, Pz same. So at point B, Py, at point A, Py, C. Understand? Now this is the container. This is the datum. This is the liquids. A points, height, depth, h from the datum or free surface. free surface. The pressure at point P at point A, depth h from the surface. We know that dp equal to dz equal to mass weight density. We know. So at free surface there is a pressure is here, pressure is P, atmospheric pressure. So differentiate this one at P atm and the pressure at A into dp. Gamma into integration of, here height is 0 and at P point height is h into dz. So differentiate P PA minus PA PATM gamma into h comma j. So P A minus P atmospheric pressure into, or also rho g into h. So pressure at point P, atmospheric pressure into rho gh. I always said this is the absolute pressure line, absolute zero pressure line, absolute zero pressure line. This is the atmospheric pressure line, and suppose this is the point A, this is the absolute pressure, and this is the gauge pressure, P at gauge. So you can say P absolute at point A equal to P atmospheric pressure plus P gauge pressure at A. Understand? So compare this equation. So P gauge pressure at point A equal to rho gh, and at the atmosphere the gauge pressure is 0. Now hydrostatics paradox theory. We know the gauge pressure equal to rho gh. So suppose this shape is this, and this is the another shape, and this is the height of this filled with liquids, and the height is same, height is h, but this is the, suppose this is the d1, this is the d2, or the d1 greater than d2. Understand? So this is the bottom face area. This is a1, this is a2, a3. This is the bottom face area. So at base, rho gh, height rho gh, p base at rho gh, and this p base rho gh. Understand? So pressure does not define pressure. This point is very important. Pressure does not depend on cross sectional area. Cross sectional area. But at this height, at the base, the f1 not equal to f2, not equal to f3, because force equal to pressure into area, cross sectional area. This is the cross sectional area. Flow of liquid from rest. This is the this occurs due to pressure difference. Due to pressure difference. Suppose this is the container, it's filled with, this is the point A and this is the point B. Its height is h1. This from the free surface is h2. So h2 greater than h2. The pressure at B points is PA. We know P equal to P proportional to H. So this, and suppose this is the container, and this is the container, a small pipe. This is the small pipe. Suppose first this is filled with liquid and this height is h1.